Hello. All right. I had to test my microphone there. So we've been working in Unit 2, doing some review for the AP test in AP Classroom. And some of the problems that we're encountering are giving us a little dose of reality, and that's okay. We've got plenty of time to tighten up any loose ends we have. In this case, we're going to focus on using our calculator to help us solve this particular problem. This happens to be Unit 2, oops, that's not what I wanted. Let me get a marker going here. This is Unit 2, FRQ-A, Problem 1. That's a 1. So there's a few things going on here. Let's just take a look at the entire problem, and then we'll break it down and get into the specific parts here. Let f be the continuous function defined on the interval -1, 8. It's a closed interval, whose graph consisting of two line segments is shown above. So f is the graph. Let g and h be functions defined by g of x equals the square root of x squared minus x plus 3, and h of x equals 5 e to the x minus 9 sine x. So we have three functions, f, g, and h. F is defined in the graph, and g and h are defined by their expressions. And then we have three questions. Letter A, we're asked about function k, which is defined as f of x times g of x, and we have to find the value of k prime of 0. Letter B, we have a new function m, which is defined by f of x divided by 2g of x, and we have to find m prime of 5. And then for letter C, find the value of x between -1 and 2 such that f prime of x equals h prime of x. So what I'm going to do is I'm going to look at each of these pieces separately. I'm going to show you how we can use our graphing calculator to help speed this process along and get us to be a little more practical and efficient and get our solutions so that we can move on to the next problem. That's pretty much our goal. Okay, so let's go to the new slide, and we're going to focus on just letter A. So here we have letter A, and right away I notice that they're telling me the expression for k of x, and they're asking me to find k prime of x, or k prime of 0. So in order to do k prime, as you know, we need to do the derivative. Well, when I look at function k, I realize this is the product of f and g. So if I'm going to do a derivative here, I'm going to need to use the product rule, and then eventually I'll want to evaluate that derivative at 0. First, let's actually write out the expression for k prime of x. In my class, I usually teach the introduction for the product rule with u's and v's, and then we say that the product is u v prime. I just wrote u prime. So u prime v, you can do it that way, times v prime u. Right? We have to multiply each of these pairs together and then add them, not multiply. My goodness. Whoever has me as a teacher is in trouble, I guess. Okay, how about this? U prime v plus v prime u. So there's our product rule. What that means for us is we are going to have f prime of x times g of x plus g prime of x times f of x. And so essentially, since we're plugging in 5, what we're going to have is k prime, not 5, 0. We're plugging 5 in a different problem here, but we're plugging in 0, so we're going to do f prime of 0 times g prime of, or times g of 0 plus g prime of 0 times f of 0. Okay? And we have expressions, I wrote x. Man, it's like Monday on a Thursday here. I'm sorry, this is a 0. We're plugging in zeros everywhere. So here's the deal. We have expressions for g and h, but we don't have an expression for f. In order to get f prime of 0, we're going to need to use the graph. And in order to get f of 0, we're going to need to use the graph. So let me bring the picture of the graph in. We'll get those values, and then I'll show you how you can use your calculator to get these values for g and g prime. So here I've brought in the graph. And if I want to find f of 0, which is this number that goes here, you just go on the graph and look for that point. And so this guy is 3. So when I do the calculation, I'm going to use 3 for f of 0. For f prime of 0, what we need is the slope of the curve at 0. And you can just do a little rise over run on your picture, and you can see that that slope is 2. I'll put m equals 2 so you know that we're doing the slope. And that means we can use 2 for f prime of 0. Okay, now the question is, how are we going to get g of 0 and g prime of 0, especially g prime of 0? Well, what I'm going to recommend is that we do that using our graphing calculator. So on the next slide, I'm going to show you what I entered into my calculator in order to complete the calculation. I've got a picture and I'll talk you through it a little bit. But keep in mind, I already know that I'm going to use 2 for f prime of 0 and I'm going to use 3 for f of 0. Okay, let's take a look at what I typed in on my calculator. So the first thing I did is I went in, just to make my life a little easier, and I entered in function g on my y1 line. Because we have to use it in a couple of different places, I don't want to have to keep retyping the square root of x squared minus x plus 3. So I entered that in on my y1. Once you have it there, you'll be able to call that function back using your vars key, right? Vars key. So keep that in mind, that we're storing our function in y1 so we can use it later. What we really want to do is the calculation though, and for that I went back to the main screen by hitting quit, and then let me show you what I typed in on the main screen. So on the main screen you can see what I've typed here, and I'll tell you what each piece is. The value of my function f was 3, so I had to do f of 0, which is 3, times the derivative of g with 0 plugged in. You can use math 8 to compute the derivative of g at 0. So I did that, math 8, and deriv shows up, and there are 3 entries, 3 parameters that get typed into that function. The first one is the function you want to take the derivative of. We already stored it in y1, so I went down into my vars, my y vars, and then functions, and I found y1. We want to find the derivative with respect to x, so that goes in the second entry. And then the number that we want to evaluate it at is 0. So using math 8, I was able to get my g prime of 0. Then we're adding on 2, which is the slope for f, so f prime of 0, 2 times the function value. If you want to get a function value for a function you've stored in y1, you just go ahead and go down to your vars menu, and you find y1, and then next to it you put the value you're going to send to the function in parentheses, just like function notation. So this is the same as g of 0 in our notation. And when I type that out and hit the button, lo and behold, I got the answer here, which we're going to say is 2.598. And that is the answer that the solution has as well, so that's good news. But I wanted you to see how we can quickly get the calculator to give us that answer. Okay, I'm going to move on and show you how I use the calculator to do letter B next. In letter B, we're told about a new function m, and m is f of x divided by 2g of x. We have to find the value of m prime of 5. We're going to attack this in a similar fashion, but instead of using the product rule, we're going to have to use the quotient rule because this is a quotient. So when I try to write out the expression for m prime of x, I'm going to run through the quotient rule, which hopefully you remember is 2g of x times f prime of x minus 2g prime of x, that's the derivative of the denominator, times f of x over 2g of x squared. That's the quotient rule. And what we're going to do is plug a 5 into this. Now before we do that, let's get our graph back up so we can figure out what the slope is at 5 and what the function value is at 5. Okay. Sorry, I thought my mic went off, but of course I'm babbling, so it's working. So here's that graph again, and let's do a couple things. Let's find out what f of 5 is. If we go over here to 5, sorry, I lost 5 for a second there. There's f of 5, so that's just going to be 5, right? F of 5 is 5. And the slope over here, if we do a little rise over run action, is down 2 and over 3, so that's negative 2/3. So the slope is negative 2/3. So that's what I'll, oops, that's a terrible 3. That's what I'll use over here. So I'm going to use a calculator again. I already have G typed in, so I don't have to mess with that. And essentially what I'm going to type in on my calculator is something like this. I need the numerator, which is going to be negative 4/3, because negative 2/3 times 2 is negative 4/3. Times y1 at 5 minus 10, because 2 times 5 is 10, times the n deriv of y1 comma x comma 5. And I have to divide all that by, and I guess I'm going to run right into my spot here, but that's going to be divided by 2 times y1 of 5. And the whole thing squared. All right. So that's what I'm going to type in the calculator, and I have that on the next slide so you can see what the calculation worked out to be. So here you can see that I've entered in the information that I mentioned. I will point out that I did type it a little bit differently with the denominator. I squared the 4 and the y1 at 5 separately. I squared the 2, turned it into a 4, and the y1 at 5 separately. But there's the calculation. Make sure you include that numerator in parentheses before you divide, okay? And then you can see I also have my denominator in parentheses to distinguish those. But when you get done, we end up with the solution is 0.171, negative 0.171, which is the correct answer. So the calculator can speed up that process for us a lot once we get used to typing these features, these keys, these functions. This is going to come in especially important in letter C, so I'm going to take some time to explain what I typed out there now. Here's letter C, and we're asked to find the value of x on the interval negative 1 to 2 such that f prime of x equals h prime of x. And I want to point out that we already figured out what the value of f prime of x is from the graph on this interval. That value is 2. So essentially what we're trying to solve is h prime of x equals 2. Well, I've shown you how we can enter a function into the y-vars, right? Y equals. And then we can find the derivative of that function if we use the n-derive feature in a special way. So what's going to happen on the next slide is I'm going to have y1 be 5 e to the x minus 9 sine x. Right? That's my h of x function. To get the derivative to graph, or to represent the derivative function, I'm going to make a new entry called y2. And there I'm going to do the math 8, which is the n-deriv, or n-derive, D-E-R-I-V. And I'm going to put y1 here using my vars key. The variable that I want to take the derivative with respect to is x. But since I want the function, I'm not going to put a value in this third position. I'm just going to put x again. I want h prime of x, and this will give us that. The other thing I'm going to do is I'm going to put in y3. I'm going to put the horizontal line y equals 2, and then all I need to do is figure out where these two intersect in order to answer this problem. So we'll graph these two, and we'll do the intersect feature, and we'll be good to go. So now here, as you can see, I've entered in the h function for y1. I typed in n-deriv with y1, x, and x there. That will graph the derivative function, h prime of x. And then here's that horizontal line for f prime of x equals 2. In the window, since they told us we were between -1 and 2, I went ahead and entered that in on the x-axis just so I wasn't getting extra information. And then I'm going to start with -5 and 3, and if it doesn't show up, then I'll find something else. But the reason I'm only going to 3 is because y equals 2 is the line we're putting in, so we don't have to be any higher than that. And what I'm going to do then is hit graph, and it's going to graph actually all 3 of these functions, so it's going to take a little bit. So I'm going to pause the video and then kick back in. Oh no, here it comes. Never mind, I'm not pausing. Too lazy to do that. So only 2 of the functions I think are going to show up. I think the other function is a little further off the graph, but we wait for a minute here. Sorry how long this is. But eventually they come in, all right? So now this is the horizontal line, and I'm pretty sure this is the derivative. What we want to do is find out where they intersect. So I'm going to go to second and hit the calc feature, which is above trace. Intersect is number 5 down here. And now pay attention to the questions. So it's asking us for the first curve, and up top, up here, it says right now we've selected the original function y1. We do not want y1. We want to see where y2 and y3 intersect. So I'm going to move to y2, and that's my first curve. That's the derivative. All right. So my first curve is y2. My second curve, you can see, is indicated here as y3. That's what we want. And then they want us to move this arrow over and take a guess. So I'm just going to guess right about there. Looks like I'm guessing 0.627. You hit the enter key and it cranks out a solution for us. Holy cow, I should probably sing a song during that time. Ooh, I was pretty close. It's x equals 0.622. That is our intersection point, and that's the solution to letter C. Okay, enough of me talking.